The topic which we are going to start today is aryl halide. I guess you all aware about the functional groups. Whenever in an organic compound, one of the hydrogen is replaced by a halogen atom, those compounds are the compounds containing hydrogen. But if the carbon chain is aryl chain, for example this, such compounds are called aryl halides. Basically, aryl halides can have halogen at the nucleus, or it can be aryl alkyl halide also, like this. Am I clear to everybody? Such compounds are called, this is benzyl halide. It can be any other chain also. So a common term is used for them is alkyl halide. Depending upon the type of compound, you can name them accordingly. If the chain is longer, you can name according to the name of the chain also. Okay. Let's move on to the IUPAC nomenclature of the alkyl halide, aryl halides. Halides are basically considered as a substituent for the nomenclature. So we always write halide, halo as a prefix, not as suffix. Unlike other functionalities, nitro and halide both are written as their substituent. For example, this is chlorobenzene. Suppose you have another substituent along with halogen atom. Maybe this one. This is called 4-chloro-toluene, because toluene can also be considered as a main compound, parent compound, or it can be para-chlorotoluene also. If you have two halogen atoms, depending upon their position, you can name them. It would be 1,3-dichlorobenzene. Suppose you have this compound. This is bromo. This is 1-bromo-4-chloro. This is in accordance with the IUPAC nomenclature, in alphabetical order we are writing. Remember, if the substituent have the same priority, then the lower number is given to that substituent which comes first in the alphabetical order. So that is why we are saying it to be 1-bromo, because bromine B comes before C. Am I clear? Okay. Let's move on to the preparation part. You want to note it down? Please note it down. You want to note it down? The properties of organic halides, halogen containing compound, basically depends upon the CX bond. It is this bond which makes the compound reactive. Basically, the bond is polar. There is a small positive and negative charge. In the case of alkyl halide, the polarity is more, but in the case of aryl halide, the properties are different because of some reasons we'll be discussing later on in the chapter. So because of that, the properties are different. Okay. I'll tell you what is the reason why the aryl halides will behave differently in comparison to the alkyl halide. Okay. Now let's move on to the preparation part. The first preparation of alkyl halide is through direct halogenation. To the benzene, just add chlorine in the presence of any Lewis acid, but it should contain the salt of, it should be a salt of this one, this halogen only. If you are taking chlorine, you can take anhydrous aluminum chloride. Just passing chlorine gas in a cold solution of benzene and in the presence of anhydrous aluminum chloride will give you chlorobenzene along with the formation of HCl. I'll tell you what is the role of anhydrous aluminum chloride in that. Same way you can prepare bromine also, bromobenzene, sorry. But ido compounds cannot be prepared that ways. You cannot prepare idobenzene in the same. There is a reason behind that, because the reaction is reversible. Why it is reversible? Because the HI which is produced is, the reaction is reversible. It will go in a reverse manner. So you will have to remove HI if you want to carry out the reaction in the forward direction. Okay. So for removing that, what we do is we generally use HGO or iodic acid, HiO3, which will oxidize your HI to iodine again. I think I can write the reaction here. HGI2. Just a minute. I'm so sorry. And in case of HiO3, it will give you iodine plus water. With nitric acid also you can do the same. Shall I write down the equation for nitric acid? You can balance the equation accordingly. Let's see what is the mechanism which is operating here. In the very first step, your chlorine molecule, which is a polar. Why do you need aluminum chloride in this case? Because it's a Lewis acid. But what is the function of Lewis acid? Why do we need any Lewis acid here? Why do you need chloronium ion? That is for the reaction. But positive कैसे बन जाएगा? Cl plus कैसे बन जाएगा? बच्चे, we are using it for the polarization of this bond because CCl bond otherwise is non-polar. Yes, it will make a complex with this, but I am saying that the otherwise the there is no electronegative difference between the two atoms. So you cannot make one Cl as Cl plus and you cannot make other Cl as Cl minus because both are equally capable of taking away the electron pair. Am I clear? So in the presence of aluminum chloride, basically aluminum will tend to withdraw the electron density from the chlorine and it in turn try to break the bond. Okay, and ultimately you will end up with a chloronium ion along with a HCl4, AlCl4 minus. Am I clear? What is the function of this Lewis acid? Yes, it is going to create, like it will help in breaking the CCl bond. Otherwise, bond is non-polar. Now, this chloronium ion is attacked by the electron density present on the benzene ring, and you will actually get the electron pair which was earlier shared between these two carbon atom is now shared between carbon and the chlorine. To either of the two carbon you can make, and definitely the other carbon is now positively charged because it is deficient. The electron pair which earlier which was shared between the two carbon, now it is shared between carbon and the chlorine atom. Now it is no more on this carbon, so it would be deficient, so there would be a positive charge on this. You know that such type of cations, basically this is called valent complex, or you call it sigma complex. WHE. Such complexes are stabilized by resonance. The charge is delocalized over to the ring. Okay. Again, you delocalize this. So there are different resonating structures which are possible. Okay. In nutshell, you can always write this is equivalent to this one. Okay. Now we know that from either of the structure you can start with. This aluminium AlCl4 minus will now act as a base, and this will abstract a proton from this. Okay, H plus. That means this proton will leave electron pair here, and the ring will regain the benzenoid structure, which it has lost during the attack on the Cl plus. Am I clear to all of you? Sure. So basically, plus HCl. Am I clear to all of you? Sure. Please note it down. You want to note it down? No. So the first method which we have discussed is direct halogenation. In the case of chlorine, you can halogenate it directly. Treat the benzene with chlorine and anhydrous aluminum chloride, you'll get the chlorobenzene. Then after a number of steps, we wash it and with caustic soda, and we separate it by different physical methods. Same way you can prepare bromo compound, but for the iodo, I told you that you will have to use an oxidizing agent, otherwise it will not be possible for you to isolate iodobenzene because the process is reversible. But fluoro compound you cannot prepare that ways. The reason being is that the fluoro compounds, the reactions are highly exothermic. The moment you try to prepare fluorobenzene by this method, the bond between the molecule will break because of the highly exothermic nature of the reaction, and you won't be able to isolate the product. So that is why we never prepare fluorocompounds by direct fluorination. We will use some alternative method. Okay. The second method for the preparation of aryl halide is from arenium benzene disonium halide. Chloride or bromide, whatever you are using. Have you done the nitrogen chemistry? Are you through with the nitrogen chemistry? Are you aware about the aniline reaction? No, you are not. Okay. That means you are not aware about disonium salts. You are not aware about disonium salts, na? Okay. See, aniline, whenever you treat aniline or any aromatic amine with sodium nitrite and HCl at a temperature of about 0 to 5 degrees Celsius, whenever you will study nitrogen chemistry, you will come to know about the details of this. I can tell you, but we won't be able to wind up this chapter otherwise. So whenever you will treat it with the mixture of HCl and sodium nitrite, it undergoes a reaction and it will lead to the formation of a compound called disonium salt. So you will actually end up with this salt. This reaction is called diazotization reaction. Okay, you will be discussing this reaction in detail, don't worry. Whatever HX you are using, that salt you will be getting. If you are using sulfuric acid, you will get bisulfate. If you are using fluoroboric acid, you will get the tetrafluoroborate. Depending upon whatever acid you are using, you will get that salt only. This is called benzene disonium halide chloride. This is a very, very important reaction because from this disonium salt you can prepare any compound whatever you want to prepare. Right now we are preparing halides only, otherwise you can prepare near about every functionality from this. If you treat this with cuprous salt, CuCl in HCl, since you can see that there is a very good leaving group here, N2, nitrogen. Remember one thing, these disonium salts are stable only between 0 to 5 degrees Celsius, and secondly, these disonium salts are stable for only for aromatic compounds, not for aliphatic amines. Okay, so that is why we are discussing in aromatic halides only. You might not have discussed in aliphatic. This nitrogen is a very good leaving group. So this will leave immediately, and basically in the presence of cuprous halide, you will get, in the presence of HCl, you will get chlorobenzene. If you use CuBr in the presence of HBr, you will get bromobenzene. So whatever salt you are taking, copper salt, you will have to take the acid of that salt only, and you will get the corresponding aromatic halide. Am I clear to everybody? This reaction is called Sandmeyer reaction. If we are using, we are changing slightly reaction conditions slightly. If we are using copper metal, copper powder in the presence of any HX, X can be Cl or Br only, not I or F. You will get that X. This is a modification of this reaction. Am I clear? The name of this reaction is Getterman reaction. If you want to prepare ido compounds, you have to add Ki and then vomit. Simply by addition Ki, you will get idobenzene. This is the best way to prepare ido compounds. Am I clear? Any question? You can ask. If you want to prepare fluoro compounds, you'll have to treat it with tetrafluoroboric acid. It will give you, can I write this way, N2 plus? You'll get the tetrafluoroborate salt of benzene, disonium salt of tetrafluoroborate, and heat it, you'll get fluorobenzene. So for preparing fluoro and iodo compound, you will have to use this method only. You cannot use any other method. Am I clear? Please note it down. Uh, I should have told you the name. This reaction is called Bals-Schiemann reaction. I think without this, the paper will not set. Without this disonium salt, it will definitely come in any or the in any form it can come, because इसके बिना कभी होता ही नहीं है. Shall I erase this? Okay. In fact, in like जो CBSE का होता है, in that also you will be getting 1 or 2 questions from this topic, from benzene disonium salts. Another way of preparation of this is from the silver salt. I've seen this question a number of times. It has come. What will happen when we treat the silver benzoate with bromine? You will get bromobenzene. The reaction is called Hunz-Sticker reaction. Am I clear to everybody? We'll be discussing few questions within few minutes, but let me wind up the preparation part. Chlorobenzene can be commercially prepared by treating. This is a commercial preparation of chlorobenzene by treating this chlorobenzene being insoluble, and it would be heavier than the water, so it will settle at the bottom in the presence of CuCl2. Copper salt they have used actually. I'll tell you, there is a purpose of copper salt actually. It helps in attack of this Cl plus. वो attack करने में help करता है. No, it is for the this salt is essential for this. CuCl2 is used, not even CuCl. This is a commercial way of preparing. Maybe the yields are high. That is the main reason, and maybe it is economical also. Okay. Please write down properties of aryl halides. Are you all aware about the properties of alkyl halides? You all are aware. Can you tell me about the solubility, their melting point, or something else? They are insoluble in water. Okay, good. What else? We all know that there is a difference between hydrocarbon and any compound containing functional group. Any functional group. It can be OH, it can be carbonyl, it can be a carboxylic group, or it can be halogen. Why the difference is there? That is why we are saying it to be functional group, because the moment you replace one of the hydrogen with halogen or with any group, the properties will change. Uh, Methane, I guess it's a gas, but methyl bromide or maybe iodide might be liquid. So the melting point and the boiling points are different. Usually, aryl halides, since you're through with alkyl halide, I guess so. So you are aware that the alkyl halides, they have more melting point, higher melting point in comparison to the normal hydrocarbon. Okay, aryl halides, they have near about same melting point or boiling point range. If you compare it with alkyl halide, there is not much difference between the melting point and the boiling point. You cannot say that it would be exactly, but there is only a slight difference between the two. But if you compare the different aryl halides, for example, uh, if you want to note it down, you can note it down also, because I'll have to write down the data. I don't remember it. If you compare different aryl halides, I'm talking about the boiling point range. For iodo, it is 462, it is in Kelvin. For bromo, it is 429. For chloro, it is 405. And for fluoro, it is 358. Can anybody guess why there is a difference between the whenever? Yes. We are moving from top to bottom because we are keeping ring, it's a fixed thing. You cannot change it. You are keeping a aryl ring as a fixed and you are moving from top to bottom fluorine, chlorine, bromine, iodine. As the size will increase, molecular mass will increase, the boiling point will definitely increase. Okay. If you move from in different isomers, if you want to note it down, I can tell you the details of that also. For ortho, can anybody suggest me something regarding the order, boiling point range and the melting point? I think you can see that the boiling point is near about the same range. There is not much difference. But in the melting point, you can see the melting point of para-dichlorobenzene is comparatively higher in comparison to the other one, both ortho and meta. There is a reason behind that. The reason is you know that it's symmetrical. Can you see that? This molecule is symmetrical. Because of the symmetry, it will fit better. So you know the melting point depends upon what? Symmetry. What is melting point? It is a temperature at which your compound will overcome the intermolecular force of interaction and they can move, because melting means you are converting solid state into liquid state. So you want molecules to move around. In liquid, the molecules are free to move. Okay. So whenever you are melting, the molecule will have to overcome the forces which are like making them sit with them. You want to move them apart. Okay. So more symmetry means there is a better fitting in the crystal lattice. जितना ज्यादा फिटिंग अच्छा होगा उतना ज्यादा more intermolecular force of attraction होगा. That means it will have to overcome that force of attraction to move away. If it want to move away, so the force of attraction it will have to overcome. So more heat will be required to overcome these forces. अगर lattice में आप इसको fit करोगे, if something is fitting best in the lattice, that means more heat is required to move them apart. So higher would be the melting point. Am I clear to everybody? Okay. Dipole moment. It is very important because they have been asking you question from this topic. Please note it down. One more thing, all aryl halides, they are denser in comparison to the, you want to ask something? हाँ हाँ सबसे कम नहीं कह सकते बच्चे, या तो either it is symmetric or it is not. Symmetry नहीं है, दोनों में नहीं है. It is just a fitting, how the molecule is like sitting उसके अंदर. The difference is not much. 5-6 degrees difference is not much. Maybe 6 degree. It is not a very appreciable difference. The difference in the melting point should be around 20. If you want to count for something, na? किसका? Boiling point is near about same range, बच्चे. The range is not very high. It is within a range of, I guess, 7 degree. You cannot say that why it is high or why it is low, because they are near about same. Whenever you yourself will take boiling point or melting point, you will observe that plus minus 5 degrees allowed. So it is within a range of 7 degree. You cannot separate them even unless you do it by fractional distillation. Okay. Next is density. All aryl halides are comparatively, they are denser in comparison to water. They have more density. Let's talk about solubility. Then we will talk some about dipole moment, which is very important. Do you think it would be soluble? Third one, fourth. Third, fourth, third. It would be soluble in water? No, why? Carbon is not polar. Molecules are not polar. When a compound is soluble in water? Okay. 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 Apart from that? Yes, it is related to hydrogen bonding. Definitely, whenever we are talking about water, we cannot avoid it. It is present inside that. You know that in water, there is extensive hydrogen bonding. All the molecules are associated by the hydrogen bonds. If you want to dissolve anything in water, the substance will have to break the bond, already pre-existing hydrogen bond, and or it should make new bonds with the water molecules. Thirdly, there is another option, it should react with the water molecule, तभी वो dissolve होगा, otherwise it will be insoluble. Are you getting my point? I'm saying the molecule must break the existing hydrogen bond. Even if your aryl halide, it will break the bond. वैसे तो it won't be able to break the bond. Even if it will break the bond between two water molecules, H bonding, and it will try to make new interactions with the different water molecules, the high energy will be required to break the bond. This you know because the bonding is extensive in the case of water. Secondly, the new interaction which aryl halide will set up with water molecule will not be of that much energy. They are not that strong. So it's a clear indication that it will be like it is breaking a stronger bond and making weak new bonds. So that is why it is insoluble. So all aryl halides, they are insoluble in water and they are denser than water, so they will always settle at the bottom. Okay. One more thing you will have to remember, you are through with alkyl halides. You are saying you are through with alkyl halides, so I'm assuming that you are aware that there can be polyhalogenated. You are aware about dichloromethane. In the case of alkyl halide, there are chances that few alkyl halides are like monoalkyl halides, they are lighter than water. So they will settle above water aqueous layer. Suppose you have a mixture of the two, so water will move at the bottom since they are insoluble and alkyl halide will be at the top. But if you have a dihalogenated compound, or I want to say it's a polyhalogenated compound, or if you have aryl halide, both types of compounds would be denser than water. So they will settle at the bottom. Okay. Mm. Without testing, you can tell me which one is aqueous layer. Suppose you have a mixture of water and some aryl halide. They are denser. Without, just by picking up the bottle, you can tell me that it's a halogenated compound, because that would be denser. Like suppose I fill uh, dichloromethane in this, or chlorobenzene or bromobenzene. So the weight of the bottle would be heavy. You will pick it up like this normally, but you will observe, you will feel that it is heavier than the normal water bottle, even if the volume is same. Am I clear? This is what we call density, mass upon volume. Volume is same, but the mass of that sample would be higher. That is why I'm saying it is density. Okay. I think we can move on to the solubility. Are you through with the solubility? Uh, Dipole moment. Write it down. I guess it is important because these are important examples. Mm. Usually, dipole moment of aryl halide is less than alkyl halide. Let's take an example. I don't have the value, so I'm just telling you if you compare it with any alkyl halide, remember the dipole moment would be less. Can you tell me why? Think about it. It's a very simple, you can answer it. It has nothing to do with the solubility. Do you know what is dipole moment? What it is? Huh. Otherwise, how do we define this? Charge into distance. ऐसे ही करते हैं. CX bond, depending upon the halogen which you are taking. So you can, I'll tell you about different halogens also. Compare. Suppose you have chlorobenzene and you have cyclohexyl chloride. In which case do you think the dipole moment would be higher? In chlorobenzene, the carbon to which halogen is attached is sp2 hybridized. This is the only difference. This is sp2 hybridized. Please change this. And this one is? Now can you tell me anything about the dipole moment? किसकी ज्यादा होगी? हाँ, तो डिफरेंस ज्यादा होगा नहीं, चार्ज सेपरेशन ज्यादा होगा. In this case, the carbon is sp2 hybridized. So you are saying the electronegativity of this carbon would be more. So the charge separation would be less or more? Less. Less hoga, because the carbon will not give the electron pair to halogen atom. So in this case, the charge separation would be comparatively more. Although the difference might not be appreciable, because I'm not telling you the exact value, the difference might not be appreciable, but definitely in the case of aryl halide, the dipole moment would be less for the same halogen atom. We are comparing the same halogen. Okay. Uh, for different aryl halides, have you done the same for alkyl halide? I'm writing this because we want to compare. This is your dipole moment. This is your Rx. I'm comparing alkyl halide. I'll tell you the aryl halide also. See, dipole moment is charge into the distance. Okay. More the distance, more would be the dipole moment. More the charge separation, more would be the dipole moment. So I think you all should agree to this point that since the electronegativity order is this, so the dipole moment for the fluoride should be the highest. Should be the highest. But in the case of alkyl halide even, it is not the highest. Why? The reason is fluoride is very small. So because of the small size, the product comes out to be a bit smaller than the chlorine. Okay. In the case of aryl halides, uh, for chlorine, it is 1.69. For fluorobenzene, it is 1.6. For bromo, maybe I have written the smaller value. I need to check the value, but the order is this only. The exact value I'll tell you, you might have that in your notes. Do you have the value? 1.7 for the iodo compound also. If you compare it with simple, although we cannot compare it because the carbon chain would be longer, but it hardly makes any difference whether it's a 1 carbon or it's a 5 carbon. Because dipole moment is between the two atoms, not with the chain. Okay, you can see the difference in the dipole moment also. I think this is justifiable that the fluoro would be lesser in comparison to the chloro and iodo. And am I clear to everybody? If you have any question, you can ask me, because this would be very important. It is because of the smaller size of the fluorine. Clear? Okay. Now let's compare the dipole moment of different disubstituted halides, dihalo compounds. This is very, very important, this part. Orthodichloro, metadichloro, and paradichloro. What can you say about the para-dichlorobenzene? Dipole moment would be 0. Why? Because because of the because it's vector quantity, you know that it will cancel. Okay. What about the ortho and meta? Remember, as the angle between, because it's a vector quantity, you might be knowing that how they add. As the angle between the two halogen atom increases, the dipole moment will decrease. So I think this is the right. Shall I tell you the values? For ortho, it is 2.54 dBi, and for meta, it is 1.72. As angle between two halogen increases, dipole moment decreases. Okay? Solubility, we are through. Stability. Yes. This is important because in few reactions you may observe that we have used alkyl chlorides as a solvent. You will observe, you can note it down if you want to note it down. The stability is of this order. Chlorides are more stable in comparison to bromides or iodides. So that is why we use chloride as a because they are more stable. Chlorides ko we are using at strength of CX bond decreases down the group. So if the molecule will be unstable, you cannot use. What is the role of a solvent? What is the role of a solvent? It will dissolve your substrate and definitely another substrate, and it will help in carrying out the reaction because the molecules are now free to move. Solid लेके दो rub करके थोड़ी ना reaction करोगे. A plus B solid, rub it thoroughly. The reaction will not be fast. If you want to do it quickly, dissolve A in something, dissolve B in something, maybe the same solvent. Or in the solvent, usually they are the same solvent. And then mix the two, then you will get the result. A plus B will give something C. So we want a solvent so that the reaction can be carried out in a faster manner. So you will use a solvent which should be inert. I'll tell you, aryl halides are comparatively unreactive towards different reactions. Secondly, it should not react with the substrate. It should dissolve the compound. अगर नहीं करेगा तो solvent का use करने का कोई फायदा नहीं है. Clear? Heading डाल लो. Properties, chemical properties of aryl halides. Remember one more thing. I didn't talk about inflammability, but this is for your knowledge purpose. Otherwise, usually halogen compounds, more the number of halogen present in the compound, lesser are the chances of their inflammability. So they are less inflammable in comparison to the other hydrocarbons. If you have benzene or if you have chlorobenzene, benzene would be highly inflammable. It catches fire easily in comparison to that. So there is a in few fire extinguisher we use polyhalogenated compounds because they are not that inflammable, they are less inflammable. Okay, reactions of aryl halides. Before starting with this, can I ask you 2-3 questions? Or should I tell you myself? Are you aware about RX? It undergoes what sort of reactions? Let's write it carbon. Okay. You have an idea that there is a charge separation between the two because halogen is more electronegative in comparison to carbon. Because of the difference in the electronegativity, there is a polarity in the bond. So it is very easy for the nucleophiles to attack on the carbon and halide ion is lost. Such type of reactions are called nucleophilic substitution reaction because nucleophile is attacking on the carbon and it is substituting a halogen atom. So that is why we are saying that they are nucleophilic substitution reaction. You are aware about this. And apart from this, other aryl halides undergo other reactions also, like reaction with metals and reaction with elimination reaction also. But in the case of aryl halides, we will not be discussing this reaction this way. Aryl halides are so reactive that they undergo substitution so easily, but aryl halides do not undergo. Alkyl halides undergo this reaction very easily. In the case of aryl halides, you will have to give some drastic condition so that the reaction can take place. Please have a look. It's very easy. You just have to put a nucleophile and just swirl it. At times the reaction is over. But here it is not. What is the reason behind that? Let's see. The first reason, and which is the obviously most important reason, is a resonance. The halogen will delocalize. The halogen will delocalize its electron pair onto the aromatic ring, and because of that, there is a partial double bond character between carbon and halogen atom. In the case of alkyl halide, carbon will have to break only one bond, carbon halogen single bond energy, bond dissociation energy. But here, since the bond order is not one, it is more than that. So the more amount of energy is required to break the bond. I'm not putting rest of the lone pairs. Are you aware about the movement of charge? Sure. You know how to make electron arrow, curly arrow rule? Okay. I guess you can see in the resonating structure 2, 3 and 4, there is a double bond. In 1 and 5, you have a single bond only. First one and the last one are different because the double bond locations are different. Okay, they are not the same. Okay, so because of this partial double bond between carbon and halogen, it is very difficult to break. Am I right? So bond dissociation energy here you will have to give. Secondly, in the case of Rx, the carbon to which halogen is attached, what type of carbon it is? sp3. Here the nature of the carbon is sp2. So the bond dissociation energy for a CsP2 hybrid bond, CsP2X bond and CsP3X bond would be different. In this case, the energy is lower in comparison to that one. Am I clear? Sure. Last. Another reason. Do you remember SN1, SN2 reactions? What happens in SN1? Halogen is lost. Carbon halogen bond is broken. Carbocation, halide ion. Secondly, nucleophile will come and it will attack R plus and the nucleophile will make the bond. In SN1, nucleophile will attack from the back side, halide is lost. Simultaneous process है, एक single step में reaction complete हो जाएगा. You are aware. If I think that can we do this in the case of aryl halide? Can we break this bond? Just like SN1? This will be phenylcation, highly unstable species, so it will not be formed. Secondly, if you think that, let us say that some SN2 type reaction can take place, nucleophile should attack and halide should lose. It is not possible because there is a high charge density on the aromatic ring. It will definitely repel the incoming nucleophile with the electrostatic repulsions. Am I clear? So there are mainly 4 or 5 reasons for this. You cannot make phenylcation because it is highly unstable. It will not be formed. Thirdly, if you think is some SN2 type reaction, if it is possible, then the halide is nucleophile cannot attack because of electrostatic repulsions. It will not attack. Clear? So do you think in the case of aryl halide it is possible to carry out the same reaction? That easy? No, it is not. If you want to carry out nucleophilic substitution in the case of aromatic ring, there are only 2-3 ways by which you can carry out that. We'll be discussing that. If you want to note it down, you can note it down. Online question, okay. Where it is? 1, 2. Okay. Yes, there is a symmetry in that. There is a question. Somebody has said that ortho. Shall I erase this? Uh, somebody has asked that in ortho dichlorobenzene there is a symmetry. The molecule is symmetric. Yet, yes, it is symmetric. There is a plane of symmetry. You can cut it into 2 equal half. But actually, what symmetry I was talking about is this one. Suppose you will have to imagine it to be a benzene ring. Suppose this is ortho dichlorobenzene. Okay. If I put an identical molecule onto this, like suppose whenever the crystal lattice will form, can anybody come? Can you hold it? The way I will say, okay. Hold it like this. Suppose another molecule will come. Now, during the crystal formation, the second molecule will have to come and sit on this. So it is quite possible that it will sit at the same, like in the identical manner, like this. Can I have another duster? No. Suppose this is another molecule. It can sit like this. The third molecule can come and it can also sit like this. One A, B, A, B, sorry, A type of stacking. Okay. There is another possibility that the molecule will sit like this. Okay. Are you getting my point? Suppose during the crystal formation, the first molecule is this one and the second molecule will sit in the opposite manner. So do you think there would be some space, open space in the lattice? There would be definitely some open space. So the lattice will not fit exactly the way it will fit in the case of parachloro. Hold it like this. In the case of parachlorobenzene, dichlorobenzene, all the molecules will sit like this only. Even if it will turn, the stacking will be the same. So there would be less loss, open space. The lattice would be best fit. Okay. you cannot correlate this type of symmetry, like if the molecule has a plane of symmetry, with the symmetry which we are asking for in the crystal lattice formation. That symmetry is different, and this plane of symmetry is different. I think और भी है. What was the last reaction I was telling you? I was telling you that aryl halides do not undergo nucleophilic substitution as easily as are alkyl halides. Because of different reason. I told you that halide, because of the delocalization of the lone pair onto the aromatic ring, there is a partial double bond between the carbon and the halogen atom, and the carbon to which halogen is attached, this is sp2 hybridized, so it is difficult for so the bond dissociation energy required for breaking the bond is slightly higher in comparison to this one. Thirdly, I told you that there is a charge density onto the aromatic rings. Because of that, the nucleophile cannot attack that easily. And lastly, I told you that if you break the bond, if you think that let's break the bond and let's make the phenyl cation, it is not possible because that cation would be highly unstable. So now let's see under what condition this aromatic aryl halide will undergo nucleophilic substitution. See, if you want to carry out nucleophilic substitution, either you will have to give some drastic condition like very high temperature, high pressure. Then only you will be able to observe the, let's see, the reaction conditions for conversion of chlorobenzene to phenol, which is comparatively much easier in the case if you want to convert methyl chloride this is easy. But in this case, it is not that easy. In this case, you will have to give about, if you are giving 6 to 8% of NaOH at about 300 degrees Celsius and 300 atmospheric pressure, then only you would be able to get it. I told you that under certain condition, we can definitely, I'll give you a few more examples about this, phenol and other product. But let me tell you under what condition you will be getting the substituted product. If you want to convert aryl halide into some other product, you want to carry out nucleophilic substitution, first thing is either give drastic condition. The second thing is you put some electron withdrawing group onto the aromatic ring so that the substitution can take place. The third way by which you can convert aryl halides into some other substitute is you have to give a very strong base like sodamide in liquid ammonia. Then you can convert chlorobenzene into aniline. I'll tell you in detail about that. So let's see by putting drastic conditions we are providing. You can see drastic condition आप दे दो हो जाएगा. Put some electron withdrawing groups like nitro. Even then you can carry out the reaction. For example, let's take orthonitrochlorobenzene. If you carry out the same reaction with at about 160 degrees Celsius, reaction is over and you don't have to give provide any pressure for this reaction. If you have ortho para dinitro compound, this I guess under at 368 Kelvin, aqueous KOH you will have to provide, and you will get 2,4-dinitrophenol. Introduction of another. More number of nitro or more electron withdrawing groups will ease out the condition. These are experimental facts which I am writing. This is a actual reaction condition under which somebody has done this reaction. We will explain this, why the reaction conditions are getting milder. Acidic property, they are not acidic. Can you explain the acidic property of haloalkane and aryl halides? Aryl halides are not acidic in nature. They are neutral compounds. In the case of alkyl halide, अभी लेना है या 5 मिनट रुक के? मैं 2 मिनट इसको खत्म करा दूं, फिर मैं वैसे उसको टाइम लगेगा. There is another question somebody wants to ask about the acidic nature of aryl and alkyl halides. Aryl and alkyl halides both are neutral. Usually they are neutral unless you put more number of halogen atom. For example, there is you might have studied this example in alkyl halides. Trihalogenated compounds, they are, yes, this proton. Acidity is basically, it's a relative term. You cannot explain acidity on the basis of that this is, suppose this is a line. Can you tell me whether it is a shorter or a bigger? Now can you tell me? And what about this? You can always say this is shorter in comparison to the upper one and bigger in comparison to the lower one. So acidity is that concept only. Acidity is basically whenever you want to say about a chemical, about a compound, that the compound is acidic, what you will have to do is remove a particular proton which you are talking about. Remove a proton, and after the removal of the proton, if the anion which is formed is resonance stabilized, I want to discuss this. Suppose HA I am writing, A can be any organic molecule, part of the organic molecule. A minus, H plus. If this is stabilized, anyhow it is stabilized, the molecule would be acidic. Okay? Clear? This is a golden line. You can apply it to any compound, whatever functionality it would be. If you want to compare the acidity of any compound, organic compound, with something else, or if you want to justify whether it is acidic or not, remove a proton, obviously, that proton should be like, there should be some electronegativity difference. We may go off the topic, but for answering this, I'll have to tell something else. Let's talk about methane also. If you want to remove this proton, you will get carbon ion. Okay. Suppose in the case of methanol, which proton would you like to move? OH. Why this one? Why not this? There was no other possibility. That is why we were saying this. We know there is, otherwise there is not much difference between the electronegativity of the carbon and the hydrogen. For a proton to be acidic, there should be electronegativity difference to whatever atom it is attached. That is why this is not formed. This is neutral. This is near about inert. It will not even react. Okay. This will come, this is highly combustible, that is something else, but otherwise in normally alkanes don't react, you know, they are inert in nature. Why they don't react? Because the hydrogens are not acidic, such the other reaction which you are carrying out with other functionalities, they cannot take place at this position. Multiple bond nahi hai, kahin pe addition nahi kar sakte, kuch nahi kar sakte. But here in the case of methanol, this proton can be lost because there is a electronegativity difference between the two. So how will you account for the acidity of methanol? Usually alcohols are neutral. If you say about the acidic and the basic nature of alcohol, they are neutral. But in comparison to something else, you can always say that they are acidic. If I compare this with methane, the pK value of methanol would be around 16, but for methane it is 43. You cannot, you will say it is acidic in comparison to methane. Are you getting my point? So whenever you want to compare acidity, write down the anion and then say whether it is stabilized or not. Now the question was, in the case of aryl halide, I'm saying that aryl halides usually they are inert. They don't react much. Their hydrogen, it is not possible to remove this hydrogen. That is why I told you there are only 3 conditions under which the reaction will take place. Under in the presence of very strong base, if you remember that the third condition was that, I'll tell you wahan par hi proton niklega. Okay, usually they are not acidic, but there are examples like trifluoro methane or trichloromethane. In this case, the proton is acidic because the carbon ion which is formed is stabilized by, oh, I'm sorry, is stabilized by the minus I effect of 3 chlorine, so it is stabilized. That is why the proton of the chloroform is acidic. Okay, this was not your query, but any other? The inductive effect of chlorobenzene is higher than the resonance effect, since it is, we will be discussing that orthopara direction. I'll discuss that, but inductive effect is not more than resonance, mesomeric effect. Although chlorine is electron, I'll be discussing that, don't worry. 1,2 chlorobenzene, there is also symmetry that we have done, है ना? Okay. We are going to discuss first and the second part. Within few minutes we'll discuss. All of you, please look at the board. Can you tell me about the reaction condition and the change you have done in your starting material? Yes, we have added number of electron withdrawing group. First we have added one, then second, and to the specific positions. You might have seen it is at ortho and para, and the number is also changing, and the position is also something, it has something to do with the position also. I should have discussed something else in between. That is why the question he or she has arise. We'll be discussing, she obviously. You can see the reaction conditions are getting milder and milder. In this case, even if you will add water and just warm it, you will get the product. I'm going to correlate that with this with the acidity question. See, it's a phenol. Do you all agree? But I'm writing it to be picric acid. It's a phenol, and I'm saying that it is picric acid. Otherwise, phenols, you know that they can be. What is the nomenclature of phenol? You just write phenol for that, na? 4-methyl phenol. I should have written 2,4,6-trinitrophenol. But there is a common name for this compound, picric acid, because it is highly acidic in nature. The acidity is unusual. It is not like normal phenols, because the phenoxide ion which is formed is highly stabilized by the 3 nitro groups. So acidity is comparable to that of carboxylic acids. So that is why we are naming it to be picric acid. Clear? So this you all agree that the presence of electron withdrawing group will ease out the reaction condition, and presence at specific positions also will ease out the condition. But before discussing that, I'm clarifying that query also, and secondly, we should have done this earlier. Uh, you remember we have done this few minutes back, that lone pair is delocalized onto the aromatic ring. Look at the resonating structures carefully. I think we all can make out that the negative charge is appearing at the ortho and para positions. We can all make out that the negative charge is appearing at ortho and para position. You know that chlorine is otherwise electronegative. So there are two effects which are operating. One is called mesomeric effect, which you can see, and another one is called minus I effect. Right now I'm telling you, in the case of aryl halides, whenever we want to carry out electrophilic aromatic substitution or nucleophilic aromatic, whatever we want to carry out any reaction, whether it is activated or deactivated towards electrophilic aromatic substitution right now, वो मैं बता रही हूँ बस. Okay. Chlorine, since it is electronegative, that is why it is pulling the electron towards itself by its minus I effect. Because of that, the ring is deactivated because the density is now pulled by chlorine atom. Okay, so by minus I effect, it is deactivating the ring. Do you know the term deactivating and activating? Sure, you all know. No, good. That's good. If you don't know, you must tell we don't know about this. See, we know that in the aromatic ring there is a charge cloud. There is a conjugation in the ring. Aromatic rings, they have high electron density. We say they are activated. Activated means they are active towards that. They are activated for the electrophilic aromatic substitution. What is electrophilic aromatic substitution? Whenever an electrophile is coming, it is substituting one of the groups of the ring. What are the groups present onto the ring? It is true for every aromatic compound. It's not only for aryl halide. What are the groups present on the aromatic ring which can be substituted? It is only the hydrogen atom. Nothing else can be substituted. और कुछ कर सकते? Whenever an electrophile will see the electron density of the ring, since there is a rule that we can put arrow that ways only, the hydrogen pair present on the aromatic ring can be replaced by the mechanism. I think you have done this, and the product which you will be getting would be hydrogen replaced by the electrophile. Such reactions are called electrophilic ring pe hai aromatic substitution, because it's a substitution of a hydrogen by an electrophile. Okay. Now the group already present onto the aromatic ring. Suppose there is a group present onto the aromatic ring. If you want to carry out electrophilic aromatic substitution onto the ring, the group will direct the second incoming electrophile. Am I clear? That electrophile can be either be directed at ortho position. You have an idea about ortho, meta and para, or it can be directed at meta or at para positions. Okay. This direction is given by, this orientation is given by the group which is already present, because it is already present over there. Okay. Now onto which position it is going, that is actually governed by the nature of the group. If the group is electron withdrawing group, then that group will withdraw the density by its effect and will deactivate the ring. It will, because the density is not because the molecule is not as rich as benzene, electron rich. I think you are aware now, you are clear that benzene is electron rich. Whenever benzene it wants to carry out electrophilic aromatic substitution. If a group is already present and the group is electron withdrawing group, it will withdraw the density from the ring and it will definitely make the ring electron deficient. Good. That means it would not be easier for an electrophile to come and sit. Okay. Remember, whatever is the group, if it is electron donating, then if it is the electron donating, the ring is, yes, that group is activating the ring towards this electrophilic aromatic substitution, because for electrophile will see more electron density onto the ring in comparison to the simple benzene. Am I clear to everybody? Remember, this is the one bottom line for all electrophilic aromatic substitution for all reactions, whatever is the functionality. Any group will show its effect at its ortho and at its para mainly, no matter what the effect is. Please listen to my statement carefully. I'm saying that any group will show its effect at ortho and at its para, no matter whether it is withdrawing effect or whether it is donating effect. Donating effect, you can see chlorine is donating the electron to the ring. You can see it is donating the ring electron to the ring, and you can observe that the electrons are mainly residing at ortho and para positions. Okay, so if it is donating at ortho and para, and if it is withdrawing, it is also withdrawing from ortho and para. बच्चे कोई भी ग्रुप है, आई एम नॉट टॉकिंग अबाउट क्लोरीन नाउ, ठीक है, वो क्वेश्चन को भी बाद में देखेंगे बिकॉज माइनस आई इफेक्ट्स उसको डीएक्टिवेटिंग मुझे दिखाना है अभी. आई एम सेइंग whatever is the group will show its effect at ortho and its para. If it is withdrawing तो वो withdraw भी ortho से करेगा और para से करेगा, and if it is donating then it will donate at these positions only. Okay, now suppose it is withdrawing. If it is withdrawing, then it will withdraw from ortho and para position. That means electrophile will not come. No. The rate of the reaction would be slower. Deactivating है ना ring. Deactivate कर दिया उसने. Suppose it is electron withdrawing group. So it will withdraw the density from ortho and para position. So it will make these sites electron deficient. That means whenever the electrophile would like to come, it will see more electron density at which position? At meta position only. So it will come and reside at meta. The arrow is incorrect because you will have to move like this. So whenever electrophile will come, it will come and attack at meta, because in comparison to ortho, meta and para, it will see more density at meta positions only. That is why such groups are called meta directing, क्योंकि वो meta पे direct करते हैं incoming electrophile को. And such groups, do you know how to identify which group is electron withdrawing? Can you identify? Can you identify? No. If the atom which is bonded to the ring has a multiple bond, for example carboxylic, It would be meta directing. No matter whatever the group is. If it is nitro, nitro has N double bond O. If this atom which is directly attached to the ring has a multiple bond, no matter where it should have the multiple bond. किसके साथ है, कौन है, कोई मतलब नहीं, कार्बन है, ऑक्सीजन है, नाइट्रोजन है, कुछ फर्क नहीं पड़ता. But if it has a multiple bond, it is withdrawing. So it would be meta directing. Okay. And remember, if an electron withdrawing group is present, the electrophilic aromatic substitutions, the rate would be slower in comparison to the simple benzene. Okay. That is why nitrobenzene undergo electrophilic aromatic substitution slower in comparison to simple benzene, in comparison to toluene. Because toluene, it is electron donating group. It donates electron by hyperconjugation effect. And electron donating groups are, what about nitrile? Because carbon, methyl and any alkyl and halogen and OH. Oh, I'm so sorry. So sorry. NH2. Or can you tell me about this NHCOCH3? Whether the group would be donating or withdrawing. At which position the bromination will take place if I carry out because all these are connected, interconnected topics. You cannot isolate alkyl or aryl halides from these. Suppose I carry out bromination at this. How will you do that? Meta. Sure. I told you how to identify electron withdrawing group. The atom which is attached to the ring should have a multiple bond. Do you think it has a multiple bond? No. It is a orthopara directing. It is activating group. Orthopara. Either you will get ortho or para. You will, I guess you will study this reaction whenever you will do nitrogen chemistry. Batao, लिख दो answer. Para or ortho both. You can separate the two. Clear? We have gone off the topic, I guess. तो वापस चलते हैं. उसका भी क्वेश्चन नहीं हुआ आंसर. टाइम 2-4 मिनट लगेंगे. Oh. So I was telling you, chlorine has two effects. One is mesomeric effect, another one is called minus I effect. By mesomeric effect, I mean that it is donating the electron pair to the ring. So basically it is not deactivating. There hai wo to activating. So it is donating the electron pair to the ring and making the electron pair available at ortho and para position. And simultaneously it has a minus I effect because of the high electronegativity. So it is pulling the electron from the ring also. Here the inductive effect will outweigh the mesomeric effect. So you actually see that chlorine is deactivating the ring deactivating group. Simultaneously the orientation would be orthopara directing. Usually if a group is deactivating, yes, it will direct, it would be meta directing. It will direct the incoming electrophile at meta position. But since here mesomeric effect is also operating, because of that mesomeric effect, the electrophile will see the electron density at ortho and para position. So that is why the orientation is orthopara, but it is deactivating. Can you write down one question? Out of the two, which will undergo electrophilic aromatic substitution faster? Chlorobenzene or toluene? In which case the nitration will be faster? Chlorobenzene or toluene? In which case nitration will be faster? कहाँ है क्वेश्चन? निकल गया, क्वेश्चन नहीं दिखा. हाँ. Although chlorine is electron withdrawing group, yet it is ortho para directing. Huh, I have answered this question now. Chlorine has two effects. One is mesomeric effect, another one is minus I effect. So because of the mesomeric effect, the electrophile will see more density at ortho and para position. But because of the minus I effect, it is withdrawing the density from the ring. So that is why it is deactivating. So this is a good question. Usually यही पूछते हैं. Is it written in NCERT that uh, we will have to? It is written. हाँ तो I have said this only. मैंने यही बोला है ना. Inductive effect is outweighing the mesomeric effect, na? Mesomeric effect is saying that it should be ortho-paradirected because, see, you cannot subtract these two effects. Suppose you have two instruments. One is for measuring the distance. Suppose you have a scale, and another one is for measuring the, what do you call that instrument? You measure the diameter of a screwdriver, diameter of a wire, screw gauge. So can you compare the two? You cannot compare the two. Same here. We cannot compare, because it's not a magnitude. You cannot compare inductive effect with resonance that subtract this and we will get this output. This is our observation that chlorobenzene gives ortho product and para product. There is no magnitude for the mesomeric effect. We cannot subtract it with the inductive and we cannot tell you that this is the output. We can say that the reaction, this is our observation, that the reaction of chlorobenzene are slower than the normal benzene. So it's a clear indication that it is deactivated towards the electrophilic aromatic substitution. Am I clear? Am I clear? By observation, we are saying that because of the minus I effect, probably it is deactivating the ring because the density is less. But since the electrophile can see the density at ortho and para position because of the resonance, so that is why we are saying that inductive is probably outweighing the mesomeric, and that is why the ring is deactivating. What is the next one? The inductive effect is higher than the inductive effect of chlorobenzene is higher than the resonance effect. Since it ortho para directing, explain. Still होगा. Still it is ortho para directing. I have already explained this, that ये अब भी आया question. Just now आया. हैं? How to identify whether a group is donating or withdrawing? ये मैं बता चुकी हूँ आपको. Donating के लिए you can डोनेटिंग के लिए ना एक चीज और कर सकते थे. आई डिडंट टेल यू. फॉर डोनेटिंग यू कैन सी the presence of lone pair, but it is not a mandatory condition. For example, phenol, or if you have suppose methoxide, it would be donating. But for withdrawing, it is necessary that you should have a multiple esters. What about esters? Withdrawing or donating? Withdrawing. Any other question? कोई रह तो नहीं गया? ठीक है. हाँ. We were at which one? Yes, you tell me. When it is 1 hour left, you let me know because I'll have to rush otherwise. 50 minutes, only 50, only 50. You'll have to. Which will undergo nitration faster? Yes, it is an activating group, so it will activate the rings towards the electrophilic aromatic substance. We know nitration is that. Okay. So I have told you that nucleophilic aromatic substitution will take place. I wanted to give you few more examples. Yes. Only 50 minutes left, no? I didn't answer few questions. I am supposed to answer them also. So please listen to those questions and then I'm going to answer. I guess we were on this track that presence of electron withdrawing groups onto the aromatic ring will help in nucleophilic aromatic substitution, will ease out your reaction condition. That too when they are ortho and para. Now you know why ortho and para. I'll tell you exactly ki hone kya wala hai. Now let's see the mechanism. Then I'll tell you why the presence of nitro group is going to stabilize it. In this case, the mechanism is basically addition elimination mechanism. I'm assuming that you have full idea about SN1 and SN2. So you'll have to cooperate for that key, you know. And right now, nobody will take off eyes from the board. Initially, your nucleophile is coming. It will attack onto the aromatic ring. I'm not putting any group onto this. I will put those groups and I'll tell you why the groups are helping and why. Can I say this is addition? I'm supposed to write neatly. Is it okay for you? Initially, the nucleophile will come and it will add to the carbon to which the halogen is attached. The moment it will attack on the carbon cannot bear five atoms. So it will immediately tend to break the multiple bond of the ring. No doubt, undoubtedly, it is going to what? Yes, it is at the cost of benzenoid structure. But we will regain that structure, don't worry. Whenever an intermediate is formed, that intermediate will ultimately give the product, and at the end definitely you will get the from either of the through. You can write down a common resonating structure also, this one. This is addition. Now the removal of halide from either of the resonating structure, from the first one or from the last one, you can write, and you will get, I'm writing from the last resonating structure. This is your elimination. That is why the mechanism is called addition elimination. Clear? Please look at the structure, resonating structure carefully. First thing, let's compare with alkyl halide. Okay, I think first thing, look at the structure. You are observing a negative charge at ortho position and at para and at the other ortho. If I put some electron withdrawing group at the ortho, like this, had it been ortho-nitrochlorobenzene, the intermediate would have been am I right? Do you all agree? The moment the carbon bearing the nitro group will acquire, the moment it will acquire a negative charge, it will get delocalized onto the group, which is, shall I raise this? थोड़ा सा ऊपर कर, चलो हो जाएगा. You can always write O negative. There is no problem. Do you all agree? See, these three resonating structures are always possible. I'm putting nitro at this. So because of the that nitro, I can get one more resonating structure. Otherwise, this negative charge would have gone at para and ortho. So in total, here I am getting 4 resonating structure. Do you all agree? This structure I am writing from the first one. The first one can go to this form also. Whenever you are putting electron withdrawing groups onto the aromatic ring, those electron withdrawing groups at ortho and para, they withdraw the density and will give an additional resonating structure. How many resonating structures are there? 3. Here you have 4. Secondly, look at the negative charge. On which atom can you observe the negative charge? जो nucleophile लेके आया? नहीं. कहाँ है पैरा पे? यहाँ. This structure is highly stable. Please look at the structures. इसके structure और इसके structures में क्या फर्क है? Stability का क्यों फर्क है? या why this is highly stable in comparison to the others? Why? किस पे नहीं है? कार्बन पे. और किस पे है? Yes. Here, an electronegative atom is carrying a negative charge. In the other resonating structures, a less electronegative atom is carrying the negative charge. So out of the 4, this is a specially stabilized resonating structure. This is highly stable. Am I clear? No? Okay. So because of the high stability, this is important. So the reaction will go. Because it is highly stabilized. एक तो एक additional resonating structure दिया उसने और वो भी वो दिया जो बहुत ज़्यादा stable है. That is why I'm telling you multiple things in one equation. That is why first thing is presence of nitro, electron withdrawing group, is going to help ease out the reaction condition. Why? Because it is going to what? It is going to stabilize this negative charge by withdrawing. Okay. Secondly, when it is at ortho, then only you would be able to see this structure. When it is at meta, you won't be able to see. Would you like to note it down? We have a very important, somebody else is speaking. We have a very important topic. I don't want to do that in hurry, so do it a little bit faster because you people were not matching with my frequency, na? So it took time. हो गया? Suppose the nitro is present at ortho. Now tell me. If not, I'm not going to write all the structures. I will tell you in brief only. Suppose nitro is present at para position. ऑर्थो वाला मेटा भी करेंगे, डोंट वरी. Initially the charge will come here. I'm going to write all the structures simultaneously in this structure only. You can do it later. Initially the charge will appear here. After that, in the next resonating structure, the charge will move. Bond will move here. Charge will move here. Now the carbon bearing the nitro group has acquired that negative charge. So there would be another resonating structure similar to this one. But the only difference would be that it is at para. No other difference is there. Do you all agree? It is specially highly stabilized. Highly stabilized नहीं बोलते, इसको बोलते specially stable है in comparison to the other resonating structures. Why? Because the negative charge is residing on. There is one more thing I will tell you. If I forget, you let me know. I need to compare it with SN2. In another one, in the next resonating structure, you will observe this charge at this position. Am I right? ऐसे ही होगा? And ultimately it is lost. So in total you will get the 4 resonating structure. But what about meta? If it is at meta, NO2 is at meta. Tell me. The carbon bearing the nitro group will not get that negative charge. If nitro, it is not coming at that, that means there are only 3 resonating structures possible. Am I right? That specially stable structure is not coming in. That is why it is not helping. Secondly, any group will have its effect at when it is at ortho or para. वही बात है. It is at meta. इसका effect वो दिखाई नहीं पाएगा. No doubt it will withdraw the density. No doubt at meta also it is going to stabilize it. It will ease out the reaction condition in comparison to chlorobenzene, but not as good as ortho or para. Am I clear? More number of nitro groups onto the ring, easier would be the reaction condition. You have seen that. Am I clear? Time. 1,1 trichloro. This is from alkyl halide, not from aryl halide. Acha. This is from alkyl halide. It is not a relevant question from this topic. I'll have to see what mechanism it can be. I'll have to see and I'll let you know because it is not from this topic. He's asking 1,1 trichloro ethane. What happens when silver powder is added to that? Yeah, the product formed will be. He's asking the same again. It's not from this topic. They have done this topic in the previous week probably, or maybe before that. Okay. So you are clear that the first thing, if you want to carry out nucleophilic aromatic substitution, you need drastic condition. Second thing, you need, if you cannot use drastic condition, then electron withdrawing group. Let's discuss few examples for drastic condition also. What happens when chlorobenzene is treated with ammonia? Usually at room temperature you will not observe any product, but at 200 degrees Celsius and 60 atmospheric pressure, initially you will get a hydrochloride salt, because you know amines are basic in nature. You will get hydrochloride salt. HCl will be the byproduct now in this case, so you will get the salt here, and this upon treatment with a mild base NaOH, slightly basic solution, you will get aniline. So this can come as actually chlorobenzene, arrow, ammonia. What is A and what is B? Will you be able to do? Uh, with CuCN also, can you write down the product? I'll tell you the reaction condition. At 200 degrees Celsius, can you tell me what will be the product? This is an extension I wanted to say. Can you tell me what will be the product? Benzonitrile. If I hydrolyze, it will become benzoic acid. So you can convert chlorobenzene to benzoic acid, depending upon the reaction condition, definitely. Clear? The third way of preparation of nucleophilic aromatic substitution is benzyne mechanism. I wanted to discuss few questions, so I want to wind up as early as possible with the thorough. The mechanism is called elimination addition mechanism. This is also called benzyne mechanism. All of you don't take off eyes from the board. Wait for a few minutes and then whenever you will treat chlorobenzene with ammonia, definitely in sodamide. Sodamide is one of the strongest base and we are using it in liquid ammonia. The chlorobenzene will give you aniline. In few books they have written this is sine substitution. I'll tell you what is actually sine substitution. So it is a slightly misleading at this moment. So what do you mean by substitution? Hmm? You are replacing one group with another. Suppose carbon is attached to halogen and you put hydroxyl ion. I'm talking about random alkyl chain. Hydroxyl will come at the carbon, see at that seat on which halogen was already attached and halogen is lost. Here it is not always essential that the product which you will get, the incoming nucleophile can occupy the same position of the halogen or it may occupy some other position also. And that position would be ortho only. That is why it is called sine substitution because it is like movement. It's a Greek word kinesis from that they have taken. It is a movement of a group to ortho position. I'll tell you within few minutes how we got what are the evidences which depicts that it is this. That is why they have termed it to be sine substitution. This is called benzyne mechanism. Benzyne clearly indicates that there is something related to triple bond. 3 bonds are there. I call it to be a 3 bond system. I never say it's a triple bond because it will not behave like a triple bond only. Now let's see the mechanism. Here, initially, in the presence of such a strong base, somebody asked this question that depict about the acidity of chlorobenzene. Here I'm going to answer. Otherwise, chlorobenzene is not acidic. But in the presence of such a strong base, the hydrogen ortho to chloro group is abstracted by that base. Okay, in the form of definitely H plus. Can I write it again? Because I want to write somewhere else. It is mandatory that hydrogen should be present at ortho position only. What is the name of the mechanism? So that means elimination of halide should be first and addition of the nucleophile should be second. In the elimination step also, this is your first step, elimination step. Basically, there are two steps. I will justify the mechanism, don't worry. I'll tell you how we got this, that first a proton is lost, then halide is lost. Initially, NaNH2 will abstract that H plus and anion is generated. That anion, it is followed by loss of halide ion. This was abstraction of proton. I'm sorry. ठीक है ना? So there would be a third bond between the two carbon atoms of the benzene. Okay, this is what we call elimination. Since we are observing a triple bond, so that is why we are saying it to be a benzene. Highly reactive species. Why it is highly reactive, I'm going to tell you within few minutes. In the second step, addition will take place. In that addition, initially, NH2 minus, which is coming from sodamide, it can be potassiumide also, KNH2. That amide, it is going to attack later on. This will abstract a proton from ammonia and NH2 is regenerated. That will be lost. So you will actually get aniline. Now, look at the board. During the addition, the NH2 has two positions to go to. Either it can go to the first carbon to which the halogen was earlier attached, or it can go to the second one to which the hydrogen was attached. Okay, since it has the chance of going to both the carbon atoms, that is why I was saying that it is called senior substitution. It has been observed. This is one of the evidence also. Am I clear to all of you? Is the mechanism clear? I'm going to justify everything why I'm saying this. This will take place first, this will take place later on. Am I clear? Okay. The first evidence that the mechanism is this: when we treated a isotopically labeled chlorobenzene, that means the carbon you have labeled. You know it's a heavier isotope. You have an idea about this. The moment you treated with isotopically labeled, the product which was formed was simple aniline along with the one in which NH2 is attached to both the products were obtained. That you can identify that nitrogen is attached to isotopically labeled one or not. That we can identify. So since both the products are being formed, so it's a clear indication that there is a movement of group. The incoming nucleophile has a chance to attack at this or at this. Am I clear to everybody? It's an experimental fact that labeled it is giving both. So there is an evidence that benzene is formed. The second evidence is when we treated a substituted bromobenzene and substituted at both the positions, no reaction was observed under the same reaction condition. So what inference will you draw? That the presence of orthohydrogen is mandatory. Without that orthohydrogen, the reaction will not take place. Am I going fast? Huh? Did you get my point? Everybody. I can be slower. Don't don't worry. Batao. Am I clear to you? I'm just saying that the mechanism can be justified. I'm saying when we treated simple isotopically labeled chlorobenzene, we thought that we should have got this product only. But we were getting another one in which the NH2 was not attached to the labeled carbon. So it was thought definitely there is something, the movement of group is there. There is some benzene formation. Later on, it was found that when we treated 2-chloro 3-methyl anisole with this under the same reaction condition, no reaction was observed. So it was thought that the ortho hydrogens are mandatory. If you will not take if you will take a compound without ortho hydrogen, no reaction will be observed. Okay. The third evidence, you want to note it down? Note down the mechanism and then. इसलिए मैंने बोर्ड का साइज पूछा था कि बोर्ड क्या साइज का है, क्योंकि मुझे लग रहा था छोटा होगा, बोर्ड बड़ा चाहिए होता है ना इसके लिए. हाँ, सीरीज ऑफ सिंथेटिक. अच्छा, 4-phenyl heptane 4-ol can be prepared from benzene. It is not from this topic. I will take it, but heptane 4-ol OH. ट्रीट ब्रोमोबेंजीन. अच्छा ठीक है, अभी बता दूं बोर्ड पे, लिख के नहीं भेज सकते इनको 5-10 मिनट के बाद. Somebody has asked, let me complete the topic, then if the time will permit I will answer the questions. It's very easy otherwise. It is from aldehydes, not from this, but you can correlate. Earlier you were writing very quickly. You are tired. Half an hour. Hurry up. Can we give them in detail later on? Mechanism. Write down, it is a reaction of 4-heptanone with the, okay. I'll give you benzene mechanism later on. I'll write it down and give it to you. There is another evidence which justifies the mechanism. The moment you treat in the 50-50 mixture of fluorobenzene and orthodeuterofluorobenzene. You know deuterio? Deuterio. When it was supplied with limited amount of NH2, it was observed after some time definitely you will get the starting material. Whenever you treat any substrate with a limited amount of reagent, definitely the starting material can be recovered as such. So during the course of the reaction, it was observed that more amount of orthodeuterofluorobenzene was present and lesser amount of this was present. So can I say that the CH bond must be involved in the bond breaking rate determining step? What is benzene mechanism? Loss of hydrogen, loss of halide, benzene formation. I'm saying that removal of hydrogen is also involved in the rate determining step. It was justified by this reaction when we took mixture of this and treated with a limited amount of NH2. Had it been excess तो दोनों react कर जाते. But जो fast react करेगा वही अपना product देगा. So it was observed that the unreacted starting material contained more amount of orthodeuteriofluorobenzene rather than simple fluorobenzene. वो तो थी no doubt, but ये ज़्यादा थी. So it's a clear indication that the removal of hydrogen is also involved in the rate determining step. Slow step है वो. ठीक है, तभी तो ये बॉन्ड जल्दी ब्रेक नहीं हो रहा है. Secondly, when the reaction of fluorobenzene was carried out in sodamide in liquid ammonia, this is also limited. We are giving limited amount. The unreacted fluorobenzene, which we observed, contained simple fluorobenzene. We didn't start with this. We started with orthodeuterofluorobenzene. During the course of reaction, we took the analycot and we found that, or maybe after the completion of reaction also you can observe that aniline is formed, but simple fluorobenzene is also present. Did you add that? We had not started with that. The presence of simple fluorobenzene indicates that before the removal of halide, hydrogen might be removed. So that means this type of species is formed which is gaining a proton from some species in the system, and that is why it is giving fluorobenzene. Otherwise we have not given it in the solution. So that means removal of hydrogen is taking place before the removal of halide. Am I clear? Sure. And the last evidence which I'm telling you, the rate of different halide reaction, rate of reaction of different halide is, okay, according to polar effect, which bond should be broken first? Fluorine, chlorine, bromine, iodine. Polar effect, bond dissociation effect, energy. पोलर इफेक्ट आपका ये कह रहा है, बहुत अच्छा बताया आपने मुझे. Bond dissociation energy would be highest and lowest. Oh, I'm so sorry. Bond dissociation high इसकी lowest होगी ना. Polar effect के हिसाब से because of the electronegativity difference ऐसा लगता है कि halide should be lost. Polar effect suggests that the order should be this. Polar effect suggests कि CF का bond सबसे fast break होना चाहिए, और bond dissociation energy क्या suggest करती है? कौन सा bond सबसे पहले break होना चाहिए? CI. दोनों opposite है. पोलर के इफेक्ट के हिसाब से कार्बन और फ्लोरीन का बॉन्ड फास्ट होना चाहिए ब्रेक. बॉन्ड एसोसिएशन एनर्जी के हिसाब से कार्बन और आयोडीन का फास्ट होना चाहिए ब्रेक, क्योंकि एनर्जी सबसे कम है. सो द ओवरऑल इफेक्ट इज ऑब्जर्व टू बी combined effect hai. Again, there is no magnitude. You cannot subtract polar effect with this. So the order which we are observing is this. This should be lower. Let me confirm. Br iodine, I'm writing. This is the overall effect. So this is the actual order of benzene reactivity. You can note it down and write down one question also. Question कितना 15 मिनट है? हाँ? I want to discuss a question. Actually, I want to explain the senior substitution, which I have not explained. With the help of a question, I'm going to explain it. Because we have electrophilic aromatic substitution also, which we had discussed. So I think वो ज़्यादा बहुत नहीं है. This is a very important question because it's a very confusing. You may misinterpret the product. Can you tell me what will be the product in both the cases? Sodamide in liquid ammonia. You don't have to elaborate it. वो पूरा लिखने की जरूरत नहीं है. Write down the benzene. I guess this would be the benzene. Here another benzene formation can also take place. This one. Am I right? Why benzene is highly reactive? I didn't tell you. Let me tell you that because वो रह जाएगा फिर. तो बहुत important है. You know that all the carbon atoms are sp2 hybridized. Now the third bond, since the electron pair is here and this was attached, suppose it is chlorine by both the atoms are sp2 hybridized. Hydrogen is lost. Electron pairs are residing in this orbital here. Want to make bond here. Bond is actually between two sp2 hybridized orbital. It is not between. Usually in open chain structures, whenever carbon is changing hybridization from sp3 to sp2, in such chain structure, the movement of atoms is possible. Like whatever the hybridization it want to take, it can retain that. It can gain that hybridization. But here it is not possible. Because the moment a third bond formation will take place, both the carbons will become sp hybridized. So for sp hybridized orbital, the hybridization, the orbitals should be like this. Do you all agree? That means this carbon is now sp hybridized. That means the bond with this carbon will come here. Do you all agree? It has to be because the orbitals are fixed. They would be linear. It is making a bond with this carbon also, na? Which is sp2 hybridized. The moment this carbon will change hybridization from sp2 to sp, this carbon will have to come over here because it can be a straight line only. This carbon will also come so that means you will have 4 carbon atoms in one line. Is it possible for benzene to occupy 4 carbon atom in one line and rest of the 2 carbon atoms like this? It is not possible. That is why the carbon is not changing the hybridization. Total there are 6 carbon atoms in the benzene. If the 2 carbon atoms are sp hybridized, that means the 2 atoms which are attached to them has to be in one line. Acetylene is linear. Am I clear to everybody? Okay. So that is why the bonding is between 2 sp2 hybridized orbitals. And you know that they are at an inclination. They are not parallel to each other. So they cannot overlap. They are like this. Am I clear? So if they are like this, so the bonding would be weak. This is little interactions are there and the overlapping is not, it's just a sideways overlapping. Proper to overlapping nahi hai na. That is why the bond is weak. So the species is highly unstable. Am I clear to everybody? Okay. Now this question. Now tell me what are the possibilities of the products. Possibility of the product. These are the 2 benzene which are possible. In this case, I guess you will say It would be ortho and meta. Am I right? Plus ortho isomer बोलोगे? बच्चे NH2 will attack at this position and at this both. दोनों पे आएगा. What about this? You will say meta and para. The same product and para. So basically you will get 3 products in this case. Am I right? Since 2 benzynes are possible, 2 benzyne बन सकते हैं ना? So 2 products from this benzyne, 2 products, and one is common in them. But you will get this as a major product, meta. These 2 are less. Why? Reason I'm going to tell you. What about this? In this case, there is only one benzyne which is possible. This one. So there should be only 2 products, and that too in 50-50%. Am I right? But you will get meta only, major. Ortho would be very less. It would be there. This is major. So the question was that meta-bromoanisole and ortho-bromoanisole gives the same major product. Why? The reason is, am I clear? Are you, do you want to note it down? बना लेना. मर्जी है लिख लो. The reason is, in this benzyne, the moment NH2 will attack, this is the carbon ion formed. इरेज कर दो एक मिनट. चाहिए मुझे बोर्ड चाहिए. The moment NH2 minus will attack, this is an ionic species which is formed and it is stabilized by the minus I effect of oxygen. But if this is formed, no such specialization is there. Stabilization, I'm so sorry. No such stabilization is there. क्लियर. तुम बोलोगे कि ये तो नाइट्रोजन का भी तो माइनस आई इफेक्ट आएगा, थोड़ा सा तो माइनस आई इफेक्ट इसका भी होगा, बट वो तो यहाँ भी है. बट जो स्टेबिलाईजेशन मिथॉक्सिल से मिल रही थी वो नहीं मिल रही है. दिस इज द रीजन यू गेट मेटा even if you start from ortho. Actually, this was observed in this case only. When ortho-bromoanisole was treated, we observed para-methoxyaniline. Oh, meta-methoxyaniline. I'm so sorry. When this was observed, then it was termed as sine substitution, that the incoming nucleophile is not occupying the same position to which halogen was attached. Okay, this is all about benzyne. It is also justified that the halide is proton is removed first before halide. Proton removal of proton is also in the rate determining step, and removal of halide is also in the rate determining step, because I told you that the way different halides react. Heading डाल लो, electrophilic aromatic substitution. This is important. You must do this. I have given this question somewhere. They will give you. कोई question आया हुआ? नहीं. Electrophilic aromatic substitution. Okay. Now you will answer me because we have spent a lot of time on this. Nitration. What would be the product? Chlorobenzene is deactivating, but it is orthopara directing. So the incoming electrophile will occupy which position? Plus para isomer. Okay. Chlorination. Ortho dichloro and para. Both have different melting, they can be separated easily. They have different properties also. Sulfonation. So orthosulfonic. Remember para product is major. एक एनर्जी डायग्राम रह गया. I'll tell you. चलो. Friedcraft alkylation, alkylation, acylation. This has been asked in one or two papers. Friedcraft वाला भी. CH3. Actually, the product is orthochloroacetophenone and parachloroacetophenone. I'm telling you, Friedcraft acylation. It can be alkylation also. Okay. Next is sulfonation. हो गया, ठीक है. Reaction with metals. Very important reaction of aryl halides. Reaction with metals. This you were aware about the electrophilic aromatics of how the electrophile is generated. You know, aromatic hydrocarbon में किया होगा. Okay. The moment you treat, we usually take bromo compounds in this because chlorine has slightly lesser reactivity. We take bromo or iodo. The moment you treat it with magnesium, it will form Grignard reagent. And the beauty of this reagent is you can prepare everything, whatever you want to prepare using this compound. Okay. With lithium also, lithium will react with this to give you this lithium bromide with the product. Now, if you want to treat it with any aromatic aldehyde ketone, you will get accordingly product. Have you done this Grignard reactions? किया है? You are aware. So you can convert this into alcohol. This is a query of that fellow, which I am taking right now. He asked me ki prepare 4-phenyl 4-heptanol. 4-heptanol. So what he could have done is you can start with 4-butanone and he wanted to prepare it from benzene. So you can always convert benzene into bromobenzene, use it by brominating it, and treat it with magnesium, you will get Grignard reagent. Treat it with the aldehyde, whatever the carbonyl compound it is. So for this particular product, you will have to treat it with CH3, CH2, CH2, this ketone. होगी query. Okay. Next is Wittig reaction. Do you know about this? In the presence of water, alcohol, you will get hydrocarbon. So if a question comes, how will you convert bromobenzene into benzene? I'm using deuterium. Bromobenzene into benzene, Grignard, followed by treatment with water or with alcohol, and Grignard is so reactive that it can abstract from a base also, like ammonia. So it will abstract from this base. Okay. The last topic is reaction with some miscellaneous reactions are there. Wittig. Can we continue for 2 minutes? One is Woods-Wittig reaction. If you treat any RX with sodium, so if we ask you to prepare ethyl benzene from bromobenzene, you can use it. Treat it with any other aromatic ring. Usually we don't take different rings because multiple products are being formed. That way you can prepare biphenyl, not di. Biphenyl. And if you are using iodide with copper, there is a special, this is called Wood's Fittig reaction. I think you are aware about that. This is Fittig reaction and this is Ullmann reaction. You'll get the same product. Okay. There is one last reaction which I want to discuss because I think it's a very important question. Senger's reagent, have you heard about it? Senger's reagent is a reagent, it's a 2,4-dinitrofluorobenzene. Please note it down because you might not find it anywhere. It's not mentioned in any of your book. It is 2,4-dinitrofluorobenzene. Senger's reagent, it is for the N-terminal determination of proteins. Whenever you have a protein chain, you want to find out how which amino acid is present at N-terminal, you use this reagent. What you can do is, you just tell me what will be the product if I treat it with glycine. It's a simple nucleophilic substitution reaction because you have two nitro groups at the ortho and para position. So the treatment with any amino acid it can be, will give you NH we actually find out what is a product and we analyze it with, there are only 20 amino acids. So we have the derivative of different 20 amino acids prepared. So we match with whatever melting point and whatever the properties are, we match with the authentic sample or with the literature and we identify which amino acid was present at N-terminal. This is from biochemistry, not from this. That's all. There is one egg reaction last, please. DDT. Okay, preparation of DDT I'm telling you because this is a part of your syllabus. Chloral, have you heard about it? Chloral. Have you heard about acetaldehyde? If you replace 3 hydrogens of CH3 with chlorine, it is chloral. Okay, and it is the only aldehyde which exists as dihydrate. Otherwise, geminal diol does not exist. Treated with chlorobenzene. One 2244 para dash chloro. This is your DDT. I'm assuming this to be 1. So at 2 second carbon, you have 2 phenyl. DDT is very important. Paul Muller invented this in 1873. It was already invented, and 1938 he said he found out the insecticidal property of this, and he got Nobel Prize for that. Paul Paul Muller, and around in 46 maybe he got the Nobel Prize. And in late 40s, we came to know, 38, he invented the insecticidal property. And in late 40s, we came to know that it is not good for health. It should not be used. It is fat soluble actually. It's a non-biodegradable. So it will accumulate in the animal body, and over a period of time, it may cause problem in reproduction. So this is a main harmful effect of DDT. That is why its usage is banned in USA and in India also. Thank you for your patience.